Welcome to this recording of Mathematics for the Trades. This is Chapter 4. We'll be covering ratio, proportion, and percent. This section is a continuation of Section 4.1, ratio and proportion. We'll specifically cover proportion in this recording. And we're going to look at proportions and solving problems involving proportions. So, different than ratios, which was the last video, so hopefully everybody saw that one because we were building upon that foundation. A proportion is an equation, and notice that an equation means that there are equal signs, and so there's an equal sign, and so the equation stating that two ratios are equal, so a comparison of two things, usually in a ratio they have similar units, at least in the one ratio, and you might be comparing it to another ratio that has different units. That's very often the case. And so you can look at something and say that, for example, 1/3 equals 4/12. That's a proportion. You can say that 1/3 of a mix of batter equals 4/12 a mixture of a larger batter, and the mixture is the same proportion within that batter. It's just going to make more of cake or whatever it is that you're making. And so we use proportions all the time. Notice that the equation is true because 4/12 actually is expressed in the lowest terms to equal 1/3. And so as all equations, they are balanced and it actually equals each other. Now, here's one thing that as a secondary and even as a post-secondary college instructor, I really battle, probably more so as a post-secondary instructor. Matter of fact, I used to teach adult basic education, and one of the things that was really, really difficult, and if this is you, you can kind of raise your hand, nobody's around, they can't see you. When you see a problem, do you just sometimes just want to go cross multiply and divide if you see an equal sign in a couple fractions? If that's the case, you're not alone. There's a lot of folks out there that did that, and did it in the wrong context. The only time that we want to use cross products is when we're working with proportions. So notice with this problem, what happens when we multiply diagonally. So if I say 3 times 4 is 12, bring down the equal sign, 1 times 12 is 12, then we say, okay, we know that this is a true proportion because we have cross products, that 12 does actually equal 12. And so we will be doing the thing later on where we go cross multiply and divide. Man, that was really fun to teach as a teacher, but it confused the heck out of a lot of students. So just remember, only time you really use cross products is when you are using proportions. So here's a cross product rule written just like the book has it in there. So if this helps you to be able to see it, I wanted to be able to include it. So we're going to find the cross products for this proportion. I'm going to pause and I'm going to let you try it. Okay, hopefully you stopped the video and went ahead and tried it. And if you did, then you can see that 5 times 12 is 60. Bring down the equal sign. 3 times 20 is 60. And so we have the cross products for that proportion. So let's look at this proportion. We don't know one of the numbers. That's okay. We'll call it x because a variable is just a number that we haven't met yet, a number that we don't know yet. But we'll solve the problem. We'll figure it out. And so solving a proportion means that you're finding the value of the quantity, in this case x, that makes the equation true. Because we know that cross products, if we multiply across both ways, and we'll find out what it is. So we will just figure out what this is, and we get to use that cross multiply and divide technique. So to be able to do this, we are going to use a cross products rule, and so I gave myself some space here, and we're going to say 4 times 12 is 48. Bring down the equal sign. X times 16 is 16x. So the rules of coefficients and variables, and so we just have the 16 as our coefficient in front of our variable x. And now we need to figure out what x is, so we're going to isolate the variable, and doing that is really easy because we know that 16 divided by 16, we'll cross that out and make that 1x. Bring down the equal sign, and what we do to one side, we have to do to the other. And so 48 divided by 16, and so you guys reach for your calculator, and if you don't have one, we'll do it together. 48 divided by 16 is 3. And so what we'll do is we will solve this by saying that x equals 3, or you could say x equals 3. So we're going to go ahead and now you can check your answer. All you need to do is just take and replace or substitute the x with the 3 right into the problem. So if we say that this is 3 instead of x, and we go 4 times 12 is 48, and 3 times 16 is 48, we can say that that is absolutely true. And we can also look at this, and that's this actually here should be over on this side, finding the cross products, because the other way to do this is to look at 12/16 in the lowest terms, and if we do that, then we say, okay, they're both divisible by 4. We do the top, you have to do the bottom. 12 divided by 4 is 3. 16 divided by 4 is 4, which is the same as 3/4 over here. And 3/4 equals 3/4, so we know that that is true, so we've checked our answer. Let's go ahead and solve this proportion for n. Again, I'll take a pause for you to go ahead and pause the recording and try this one on your own. Okay, so let's go ahead, and we have 6 over n and equals 15 over 10, which is just fine. If we have a bigger numerator than the denominator, that's okay. We'll still go ahead and apply the cross products rule. And so we'll go n times 15 is 15n. Bring down the equal sign. 6 times 10 is 60. Let's go ahead and, so that's the cross product rule. We'll go ahead and solve the equation where we can say that 15n equals 60. Isolate the variable by getting rid of the 15. 15 divided by 15 gives us 1n, or n. 60 divided by 15 gives us 4. And so 4 is our answer for this problem. Hopefully that's what you got. We can substitute 4 in for the original proportion. And so up here we can go ahead and put that as a 4 up here. 4 times 15 is 60. And 6 times 10 is 60. And so we have that is true. So one of the things that's important is just to remind you that the variable can appear anywhere in a proportion, in either side of the ratio, either in the numerator or in the denominator, as long as there's only one variable. And you just solve the proportion the same way. You notice that I have a habit of going from bottom left to upper right and upper left to lower right. It's just a preference of mine. Some people like to go the other way, but remember, you have to draw a diagonal. You can't go either up and down vertically or horizontally. So make sure that you're always doing the diagonal on that. But it doesn't matter where the variable is. So let's go ahead and apply this to, again, my roofing experience. And matter of fact, I'll be roofing a tiny house tomorrow. So this is applicable. And so if the pitch of a roof is 2/12 or 2 to 12, and remember roofers like it with the denominator being 12, and the run is 20 feet, what must be the rise? So pause the recording, read it, reread it, think about it a little bit, and go back at your notes if you have to, and remember what is pitch, what is a pitch, and what is this rise and run thing. So try to remember that and take a pause. Okay, great. So we're back. So let's go ahead and try to solve this together. If you're scratching your heads going, I don't remember what it is. That's right. Pitch is rise over run. So what does that have to do with proportions then? How do I solve this? Remember that a proportion has to do with, it's a comparison of two ratios. And so in this case, we're going to look at the rise over the run. And we can say that the rise over the run is 2/12. Okay, that's great. And a proportion says then that it's going to equal another proportion or another ratio. And so I see in my problem here that it says that there's a run of 20 feet. So if this is rise over run, and run is always in the denominator, the bottom, then I can say that I know that that's 20 feet, and it's asking for the rise, so I'll just put that as r instead of x this time. That's fine, doesn't matter. And then go ahead and you can solve for this problem. So they've already done it over here, so we'll look at it and see if it came out the same way yours did. So the cross products in this case are 12r, and so 12 times r and 2 times 40 equals 40. And then they're going to solve for r by taking 12 off of each side, and you end up with 3 1/3. And so the rise is 3 1/3, or you can say 3 foot 4 inches, because remember, a third of a foot, if you break it up into 3, it's 4 inches each. 4 times 3 is 12 inches in a foot. So 3 feet and 4 inches. And so then you can say that that is the rise when you have a 2/12 pitch with a run of 20. All right. So here's another one, and this is for our students in the health sciences, which we have quite a few of you. I had to dig around and find these. It won't all be roofing and industry, that they have a whole lot of those, but I'll try to dig up as many allied health and health sciences as I can. This is a really important one for everyone to know because it's part of the course content guides as well, in that it really looks at problems where you're having different mixtures. So go ahead and try to do this problem. Set it up as a ratio first, and then set it up as a proportion and solve it. Make sure you look at the units on this one and get an understanding of the unit. So I'll pause, let you kind of soak that in, try it, and then we'll come back. Okay, so let's go ahead and look at this problem. This is different than anything else that we've had. So for medications provided in a liquid formula, the amount of liquid given to a patient depends on the concentration of the drug in the fluid. So they've got a medication, call it X, we don't know what it is. It's available only in a liquid formula, and it has a concentration of 100 milligrams per milliliters. So that's going to be important to remember. It's 100 milligrams per milliliters. And suppose that the physician orders 225 milligrams of this medicine, how many milliliters will be dispensed to the patient? So one of the things we need to do is we need to make sure that we set this up understanding what we've got here. And to do that, let me give you a hint. To determine the amount of the liquid that's required, note that 100 milligrams per milliliters means that for every 1 milliliter of liquid, it contains 100 milligrams of the medication. So 100 milligrams per milliliter. Okay, hopefully that's helped, and so you can pause it and try that. Okay, see if that has helped you set up the ratio. So we can go ahead and set up the following proportion, and we're going to set up where we have for every 1 milliliter there are 100 milligrams. So we're looking for how many milliliters are in 225 milligrams. So again, milliliters is that fluid volume that we're filling. Something that's really important on here that I wanted to make sure to point out to everybody, and that is that, oh, just a second, let me see if I can get this real quick. My eraser tool is not working here. Oh, here we go. Okay. And that is one of the things that's really important to look at and see here, and that is that our units are the same on both sides. So it's milliliters over milliliters, milligrams over milligrams, because what we're comparing is we're comparing the 100 milligrams in a milliliter, and now how many milliliters are needed for 225 milligrams of medication. But notice it's important that the units are always on the same side, and that is so you can reduce them. Remember, that's when you see a line here, when you have a line, that means divide by, and you need to divide by like terms, so, or like units, so milliliter by milliliter, milligram by milligram in this case. So let's go ahead and look at this. When we solve for x, we're going to cross multiply and divide, and so from that we will get 100x equals 225. Go ahead and solve for x. So you should get 2.25 milliliters, and the patient should take 2.25 milliliters of the liquid to be able to get 225 milligrams of the medication. This is the last problem in this recording, and we'll go ahead and move on to the next one. Join me for the next part of Chapter 4.